Hey guys, now that we have covered binomial expansions, the next step is to evaluate a generic term inside an expansion. So we're going to evaluate the kth term of a binomial expansion. So let's say you want to evaluate the 99th term, the 99th term of this expansion. Let's say it's 2x plus 3y to the power of 101. So it would be a terrible idea to try to open this guy, right? It's practically impossible, but after this class, you'll be able to do that without expanding the whole thing. So just to review some basic concepts, the binomial expansion of, let's say, a plus b to the power of n is equal to n choose 0, a to the power of n, b to the power of 0 plus n choose 1, a to the power of n minus 1, b to the power of 1 plus dot 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 plus n choose n minus 1, a to the power of 1, b to the power of n minus 1 plus the last term n choose n, a to the power of 0, and b to the power of n. We know that b to the power of 0, which is this guy, and a to the power of 0, which is this guy, they're both 1, so we could have omitted them. We can write this whole thing as a summation, so we have a sum from k equals 0 to n of n choose k, and a to the power of n minus k, and b to the power of k. This is really similar to the generic term. We're going to see it in a few moments. But let me just say that, let me just write down how we can calculate this guy. So we have n choose k. What is this? This is basically n factorial over k factorial and minus k factorial. It's this guy over here. So we know how to calculate this binomial coefficient. Just as a matter of proving something, let's write down the expansion of a plus b to the fourth power. This is, you can verify by using this formula here, but this is basically a to the fourth power plus 4a to the third power times b plus 6a squared b squared plus 4ab cubed plus b to the fourth power. And let's use the formula which I'm going to present right now to evaluate a generic term on a expansion, and we're going to prove it by using it in this example over here. So let's say we want to calculate, this is the first, second, third term of this expansion. So this is the third term of this expansion. How can we find this guy out? We can use this formula over here. We have t, which is the term k plus 1. It's going to be equal to n choose k, a, n minus k, and b to the power of k. So this is the formula to calculate any term inside a binomial expansion. So let's use this guy for this example and prove that it's actually correct. It actually works. So if we want to calculate the third term for this guy, so we need to find this guy out. What we can do is set k to be 2. This way we're going to have t2 plus 1, which is the third term. This is the third term, which is equal to n. And what is n? N is this number over here. It's the power of the binomial. So we have n, which is 4. 4 choose 2. We're going to use 2 since the k here, it's actually equal to 2. times a to the power of 4 minus 2 and b to the power of 2. So we're going to have something like this. 4 factorial over 2 factorial times 2 factorial, which is, let me just write down this way, 4 minus 2 factorial to keep the structure of this term, times a to the power of 4 minus 2, which is just a squared, and b squared also. We know that 4 factorial is 4 times 3 times 2 times 1, so this is 24. 2 factorial is just 2 times 1, which is 2. And this guy, it's going to be 2 factorial also, so it's 2 over here also. So we have 24 over 4, we have 6, a squared, b squared. So it's proved that this formula actually works. We just found this term over here. We just found the third term of this expansion. So now we can go back to our initial problem, which is to find out the 99th term of 2x plus 3y to the power of 101. It's going to be a big term, of course, because the power here, it's very large. It's going to be a really large number. We're not going to evaluate it until the end, but we're going to find out what term it is. So to find the 99th term, we need to set our k to be equal to what? Our k needs to be equal to 98. So we have tk plus 1, which is the term 98 plus 1, which is actually what we want, which is the 99th term. This is going to be equal to n, which is 101, choose k, which is 98, times our first term here inside the binomial, which is 2x to the power of 101 minus 98, times this term, which is 3y to the power of 98, and we have this very large number here, 101 factorial over 98 factorial times 101 minus 98 factorial times 2x to the power of 3, which is 101 minus 98, times 3y to the power of 98. And this is the 99th term of this expansion. So it's going to be a really big number, really large number, because of this guys here and this one. But this is definitely the 99th term of this expansion. So if you want to receive this type of video and much more, please subscribe to the channel, and I'll see you in the next class.